Welcome back, and we got a new video, and we're gonna continue particles. This time, we're gonna finally do the grass. So we're gonna have a field of grass. It's gonna have a swaying motion, so it kind of feels like wind's blowing through it. So, so as you can see, there's a bunch of grass on the screen, and a quick and easy way to find a good image is by searching actually billboard grass. And I found one down here from Unity Forums. Click on it. I just went and saved this file right on the desktop. So there's a bunch of grasses you can probably get if you really want. You probably should always check to see the royalties of whatever grass you use. And make sure it's a power of 2, because we were dealing with textures. So this one probably wouldn't be too good because it's not a power of 2 texture. This one is, it's 512 by 512. This one is not so good. Not so good. Like, I picked this one because it's simple and is a 5 by 12. It's, like I said, it's a power of 2. So that's one, the power of 2. That's also a power of 2 one. That one, definitely not that one. But you get my drift. And there's 2 types of grass you can do. You can do the flat one quad, which you have to use billboarding to facilitate it, to make it like look all right. And you'll see how it looks with billboarding set up for it. And then you have this example. And this example is where you kind of, in this instance, I think this one's using 1, 2, 3. Is it 3? I think it's using 3 or 4 quads. And it kind of uses the exact same texture. You can actually use multiple textures, and it kind of lets you build like a 3-dimensional piece of grass. So that's another approach you can go about it. But that, let's say, for every piece of grass, you have to have 3, anywhere between 3 to 4 quads. I think normally you can actually get away with 3 quads, but in this image, they're using 4. But we're going to use the cheap, simple way, just 1 quad, and we're going to use billboarding. Like I said, this one doesn't have billboarding because it kind of just it makes it look 3-dimensional by the simple fact that we're making kind of like a cylinder type of shape out of quads, and then kind of having everything kind of blend in together. We're not doing that. That's something you can do as a challenge, just by mixing and matching, and make that a single particle, and then have that repeated. So that's definitely a challenge for you guys if you want to try it that way. So this way you don't need billboarding. But we are going to use billboarding. So like I said, I wanted to continue that, and I like the idea of making it sway and everything. In this lesson, I had to do quite a bit of changes to fungi. One thing I did is upgraded our UBO. The UBO, we had a video about that a long time ago, and the UBO allows us to basically kind of set up one set of variables that we can just push to the GPU once per frame, and then all our shaders can access it. So this way we don't have to push certain data to all our individual shaders. Kind of like our camera matrix and our camera position. We don't want that in our projection matrix. We don't want to actually have to push it to every single shader at every single frame. So the new variable I'm adding is F time, because we're going to do a lot of animations, and I was starting to push time into our shaders. And when I was making this video, I was like, all right, I need to build a way to make time automatic when it comes to shaders. Then I was looking around, I was like, you know what? What makes more sense is by putting it in the UBO. Just apply it once at the beginning of the frame, and every shader will automatically have access to it, as long as you have the UBO set up for the shader, which is very easy to do. So I don't want to go too much into this, but that's, like I said, that's kind of an important thing, because it's going to help animation down the line, because time is very important to animation. I'll just quickly, like I said, the orbit file changed because the UBO was in there. I pulled it out. Now it's in fungi. Like I said, I have a new variable, because before it was just these 3. Textures. I brought textures back into the module version of fungi, because we lost the ability to do textures for 20 videos so far. I brought that back. I'm not really going to go talk too much into it. If you look at here, you can see all the new code for it. The new shader changes, downloader, the ability to load and download images to textures. That's a new feature. So if you care about that, you can look at the new source code for downloader in downloader.js. And the shader just been fixed up so it can handle textures again. That's everything here is kind of just related to textures, really. Yep, just textures. And that's just their test. Anything else? So yeah, those are all the changes. This will be in the README for this lesson. A link directly to the changes. Like I said, if you didn't realize that, for every lesson I try to make a commit that handles all the changes to the fungi. So instead of me spending the video talking about every single line of code, I kind of just quickly breeze through it, and you guys can kind of just go back here and change it manually, or just grab the entire code base from GitHub. All right. So here's some grass that is currently working now. So now let's look at the actual source code. So our first order of business is we need to load in our texture. So we're going to load in our texture. I'm going to have MIPS turned off, but I need the Y flipped on. So it brings it in upside down. In this, we're still going to, there's some changes to the emitter. So the emitter has been upgraded since the last video, so it can handle single shader effects. So this way we don't need a transform feedback to produce animations, but we still want to be able to facilitate all the buffers and instancing and everything else. So this example is how to use the Mesh Emitter, but without the transform feedback. And like I said, I did this small changes here and there. But everything else, as you can see, is the same from the last video. We're still building our quad. We're going to build 10 particles. And our offset is going to be the random location of each blade of grass. So the offset, I need to handle X, Y, Z. So it's particle count times 3. 3 components per particle. And that creates me the array. And then I just fill in the array with this information. So while I'm dealing with X and Z, I want a random number. I know this looks a little scary. It's hard to kind of visually see it, but I'll try to best show. This is a delegate for using like for each function. So it's basically an anonymous function. V is value, so it brings in the value of each. So what for each does, it loops through the array and then gives you back like a bunch of references. So V is the value of a particular index, which is I, index, inside the array, which is A. So you actually get all 3 values when you're dealing with for each. So it passes in the value, the index that the value exists in, and what array that index and value actually exist in. So by getting all 3 values and use the for each function, I'm able to kind of just go and actually update all the values in the array. And in this case, I'm doing a modulus 3 because it's every 3 components, and I'm going to check to see if it's not 1. Why 1? Because a modulus will give me between 0, 1, and 2. 0 will be X, 1 will be Y, Z will be 2. So if it's not 1, which means if it's not Y, create a random number. And the random number is going to be between -10 and 10. If it is Y, I want it to be a static value, or 0.5. So I want the particle to be random on the floor, but height wise I want it to be flush on the floor. So that's offset. And then this is our buffers, and like I said, we don't need transfer feedback, so everything's a static draw. And the first 2 are our quad information, and offset is our instance value. And all this runs through one shader. So we're not dealing with 2 shaders with this one. It's just a single shader. It takes care of everything. And offset is, like I said, that would be the instance a buffer. So if we put in like 10 positions, we're going to create 10 blades of grass in those 10 positions. Everything stays the same. Let's see. So what kind of changes we did in particles? One of the things I did in that changed in particles is I have a variable called use feedback, because like I said, now we don't have to use feedback all the time. We can use just a single shader to actually produce our animations for our particles. So in setup, we call before I used to say setup feedback, and setup draw view. I did all three of them. Now I'm actually going to process the buffers, and setup buffer counts how many feedback buffers are created. So if I get more than one feedback buffer, then I actually create the feedback buffer and do that. And actually, to be honest, what I should do, to me, it makes more sense to actually copy this into setup's feedbacks, and then make this a small loop, something like this. Yeah, this makes more sense. So this, I like one-lined code if I can. I like this. This I prefer. This makes more sense. So this way, I don't need that anymore either. So this makes more sense, and I like things lined up just right. Sorry, when I see bad code, I have to fix it. So if setup buffers creates more than one feedback buffer, then I set up feedback. Inside feedback, I save the variables saying, okay, we're using feedback, because drawing needs to know that. So in setup feedback, I do like a feedback count. On top of that, I also check data. This is a new little thing, because this actually gave me a big bug. And then I wrote this code in because I was passing in arrays, and this needs to be a float 32 array. So it gave me this weird error, and it took me to realize that it's because it wasn't a float 32 array. So if the data is null, you calculate how big you want the empty buffer to be. If it's not an instance of float 32, you make it an instance of 32, else just dump it in there, and that's it. And it just dump that information into the buffer. And then right here, if it's you're using the bitwise operations, if it is I'm checking to see if it's 1 or 2, because it's a read or write buffer. If it's not equal to 0, then it is a read or write buffer, and just add to the count, and that's what I return. So that in setup, that's how that setup works, and call feedback. And our feedback functions the same way like the previous video. I don't think nothing really has changed in here. I don't believe. I don't think so. And then our draw VO. The only thing that changed in our draw VAO. That's another thing I'd change. In the previous video, this was filled in automatically. This is not filled in. Now it's set by null by default. And then these setup functions kind of created. So if there is a feedback, I then create these structures on the GPU. Same thing when it comes to draw VO. It creates a single array. But if we're using feedback, I need to create an additional VEO, because I need to bounce back and forth between two VEOs. And then I just change the for loop, so this way it creates one at a time. Again, don't need this console either. Save. And the rest stays the same. So this way, setup draw VEO can either create 2 VEOs for feedback buffers, or just one VAO just for regular single shader rendering. And then our draw function checks to see use feedback. And if it uses feedback, all this code got dumped into the if statement. If we're not using feedback, we're just going to bind the 0 element draw VAO, and we draw our instance, and we call it a day, and that's it. And that's really all to it. I don't want that. So everything still works just fine, even though I did some changes. And now you'll see, you might notice that our grass moves. It's swaying a little bit. And no matter which direction I look, it's always it's using the cylindrical billboarding. So when I move, it always tries to keep pointing at me. But this way, like, it's realistic, essentially, doing it this way. Instead of using spherical, if it was spherical, it would look really bad. Keep going back to this one. I don't know why. There we go. So the last thing to really get, like I said, this all creates the grass. There's nothing special. We just created particles. We're just creating a single shader, and that's it. And the shader code, it's almost identical. The only difference is now we're passing in our texture. And then I set up the uniform texture with texture name. And again, this text 1 comes from up here. Right here when I'm loading our texture, I'm giving it the name text1. So our shader knows in our materials for text01 to use the texture in our resources called text01. That's one change for there. This, like I said, it's almost identical. We need this because we're not using feedback, but we're using the same variable offset. We don't need any of the age stuff because we're not calculating age anymore, because we don't need age, because grass doesn't need to be age. And we're getting our billboard stuff, and I'm using the cylindrical. If you don't like the cylindrical and you sphere, then you see what grass looks like, and that does not look right because it's always facing us. That's not right. So that's why we need cylindrical billboarding. So this way grass looks more natural when we zoom out and we rotate our camera. Okay, so like I said, the previous video I talked a lot about billboards. So I just now wanted to show you the difference between the two billboards when we're dealing not with particles but with something different like grass. So the last bit of code really, oh yeah, that's right. And here's F time. It's part of our UBO. So time is very important to animation. So swaying. How do we sway? Swaying is it's actually a very simple thing to do, especially when you're dealing with quads. Now, let me do this. Temp.a equals 1.0. Refresh. There we go. Now you can kind of see our grass, how they really kind of look like. As you can see, they're quads. You see the points right here, right? So the way that the quad is put together, it should be. Yeah, there they are. So the way the quads are put together is that this point is 0, that point is 1, that's 2, and that's 3. So those are the 4 points in our quads, right? So the idea is I want to keep point 0 and 1 in place. They're like the roots, and I just want to move the top points. So since we know that's 0, that's 1, that's 2, that's 3, that means all we need to move is 2 and 3. So if you're going to move 2 and 3 on an X-plane back and forth, that's golden. So like basically we're skewing the quad. And skewing the quad allows to make that kind of flowy back and forth thing, motion. So let me comment that out so we can see our textures properly again. Now, so keep in mind that we're looking for anything between 2 and 3. So I'm using something called GL vertex ID. Vertex ID is the index of the vertex in our vertice array. So if we're rendering vertice 0 and 1, we don't want to move it. We want to leave it where it is. If it's 2 and 3, we want to change it. So that's why it's vertex. I'm using the vertex ID greater than 1. So if we want to sway back and forth, one of the best things you can use is cosine or sine. Cosine and sine, you can just dump in any number you want, and if it's incremental, it will sway back and forth between -1 and 1. That's exactly what we want to do. So right now, I'm actually passing in instance ID. Now, why am I passing instance ID? If I don't pass in instance ID, refresh, all the graphs will sway exactly the same. They will sway back and forth exactly the same. That might look good depending if you're showing that a lot of wind is happening and everything's blowing in one direction. But if it's swaying back and forth, it looks kind of unnatural for all the graphs to sway at the exact same tempo and also at the same tempo and at the same direction. So by using index ID, and like in the previous videos when we're dealing with index, it's the same idea as vertex ID, except each index gets an index value. So the first grass that's rendered gets a 0, and the next one's 1, 2, 3, so forth. So we take time. So time is a constant increment. We want to shrink it down because we want to shrink time very slowly because we don't want it to be so fast. Like for an example, if I can show you this. By changing that value, now the grass sways back and forth really fast. So like I said, time is important for animation. Now if it's like really, breezy out and, that makes sense. You want a lot of crazy flowiness. But trial and error, this was a good number times time. So basically, like I said, I'm getting a small fraction of time and I'm adding the instance to it. So that means because if this way, every instance has a slightly different value being put into sine. So this way it's unique. If I didn't have it didn't add the instance ID to it, every single instance will use the exact same time and the exact same increment. So this way it kind of makes each one slightly unique. So each one kind of flows at a different point in time. So this way it looks more natural that all the grass changes. So that's why we're doing it that way. So that's why this way we don't need extra bits of data to bring in like a random seed. Our instance ID basically is kind of like a random seed a little bit. And then when all said and done, we all dump that in the sine function. The sine function spits back something between -1 and 1, and we multiply it by -2. -2 is how far we want to skew the top 2 points. So if I want to skew it by a lot, let's say I skew it by 9 instead of 2, refresh. See, now it kind of stretches out a lot because that's how far I'm skewing the top 2 vertices. But like I said, for trial and error, 2 seems to be what works really well with this grass. See, it's a nice slow progression. It's a slightly breezy day. That's all. It's a very, very light breeze in this field today. And everything else is practically the same. We take that position and we multiply by all our matrices in the end. And like I said, all we need is billboarding and a little bit of numeric magic sprinkled on our just 2 vertices on our quads, and we can then skew and make it and simulate the idea of grass flowing from the wind. We simulate it, and like I said, you just tweak this to fit whatever you want. And you might say, why am I doing X? Well, the quad exists in the forward direction, and after you do it in the forward direction, it's easy to just change it. So before we do anything to our quad, I'm going to skew it a little bit, and then these matrices does all the rotation for us. No, you know what? I'm confused. You know what? I wonder, should I do that before I do billboarding? Let me see. I haven't tried this. Thinking about the order of operations. I probably should do that. Let's see what it looks like. Yeah, I think that one looks a light better. Because I think before there was a slight kind of weird effect happening. This one's better. Okay, so the order operations, I think, is better to actually modify skew our quad first, and then we rotate it based on a cylindrical billboard rotation. So then we rotate the vertices, and then once we have that vertice rotated, then we can do more transformations on it based on the camera projection and model. Which is pretty much the whole emitter. The whole emitter is a single model, so we can move that emitter, and everything that emitter emits, that renders, moves along with it. So yeah, that's better. I like that. That fixes it. Empty cache, and there you go. So we improved it, much better. I think it's not as bad. I don't know. I think it's fine. So that's grass for you. But you know what? The field looks kind of empty. That's a really sad grass. A field grass. Field of grass? I don't know how to call it. Let's bump it up. Let's make 100 bits of grass. Empty. There you go. Now let's make it look, and that kind of looks kind of like a desert kind of thing. If I had like desert sand, this might be more deserty looking. How much grass we got. And you can kind of see each blade of grass kind of flows independently from the others. Some are in the same, some are not, some are slightly delayed. But like I said, we kind of want that slight randomness without random. You know, you don't have to use a lot of crazy math to do it. Sometimes like sine wave and just incrementing goes a long way. What else? Let's go up to 1,000. That's what the field looks like. There we go, and that's looking much better. Oh yeah. See now I'm like my wife's been playing Assassin's Creed Origins a lot. She loves Assassin's Creed, and now you can pretend that we are an assassin and are hiding in the bushes, and you're kind of looking around for Templars. You know, it's like, where's the Templars? Because the Templars can't see me hiding in this grass field. So there you go. That's looking pretty good. Look at that. We got a nice field of grass. Low poly-ish, but whatever. Let's go for broke. 100,000. 100,000 blades of grass. Oh, now that's what I'm talking about. That's a good field of grass. It's like a cornfield. Yeah, this makes me look, and everything just looks like a nice breezy day out in the field. That looks awesome. And it's animating great. You got to think about it. It's like, look at that. Look at all that grass just animating away. Now it looks like fur too, if you think about it. Oh, that's not bad. That's because of the billboarding, because it's cylindrical. So if you're perfectly right on top of it at a 90 degree, you can't see it. But yeah, man, that's freaking awesome. No, those Templars can't see me now. Can you see me? Can you see? Whoa. Now the Templars can't see me. Oh. So disorienting. Let me just do 10,000. I think 10,000 would be a nice. It There you go. A little break up here and there. That's pretty good. That's still pretty good though. Even that looks. I think that looks a lot better than 100,000. And I like the slow swing. That'd be awesome. Like I probably should do it right now, but I don't feel like it. But put like a cube right in the center and just see what a cube looks like in the middle of a grassy field. But yeah, there we go. We got grass, and it's using our emitter. This is like, even though this doesn't necessarily look like particles, you can you can still consider this particles. You know, just a bunch of quads, and they're animating in a certain way. And this is a nice random field of grass. So there you go. More particle effects, and we got grass. Maybe down the line in the future, I'll start building more terrains, and we can dump all this grass emitter right on top of it, so we can have some really cool stuff in the future. But like I said, it's been almost a year, and we're starting to get to the point where we're going to start building things. Some really fun stuff. I can't wait till we have a character controller, so we can have a character run around. That's definitely in the works right now. I finished 3D modeling Bendy from Valve, and I'm trying to get it to animate a little bit. First, I want to do some poses and see if I can load up the poses and transition poses. And then once I can get that working just right, then I want to do animations, like walking animations for Bendy. If you don't know who Bendy is, Bendy, Valve, what is Valve the Lab? So these guys. Bendy's house. So I 3D modeled one. So I 3D modeled a Bendy, and I got his hands and legs and head and its torso with an armature all set up, and everything bends. I had to do all the weights and everything else. So I got all that set up. So I need to kind of do poses and animations, and then like a simple walk animation, maybe a jump animation. I kind of did like a Naruto running pose. I think I posted it on Inger. Naruto Bendy Naruto run Imgur. There it is. This is what I posted. Bendy doing ninja run. So this is an example. This is actually mine, Sketchpunk. So I like I said, I modeled 3D Bendy, and I got everything kind of almost working. I fixed up the arms. The arms are bend better. But yeah, I want to have Bendy do a bunch of fun, cool animations. We're gonna bring it into the into a web page and animate it, control it, and that will probably be our character that we use for a lot of for like maybe the mini game. I'll probably eventually want to build up using WebGL and Fungi. So like I said, we're gonna have fields, we're gonna have terrain, and we're gonna have someone that we can control. So this is gonna be in the future lessons. When I go back to Armature, I'm just gonna do maybe 1 or 2 more videos of emitters and particle systems, and then go back to armatures. But like I said, this is something on the side I'm doing as well. So yeah, this is gonna be fun. So Bendy is gonna be a fun character to play with, and because I'm not a great 3D modeler, it's an easy thing for me to make, for the most part. It took me 3 or 4 tries, but I got it working just right. So there you go. There's our grass. Soon we'll have Bendy running around in it with some terrains. So I hope you guys are enjoying yourself. I hope you enjoy the learn how to do grass. What you also could do is do variations of grass. Like if you did like 3 or 4 different textures, maybe make an atlas out of it, and then this way the field of grass will actually look more natural, because there'll be a good amount of variation in it. So just another thing you can do to improve, because it's usually good to have multiple types of grass, not just one grass that repeated like 1,000 times. Different colors, slightly different colors, something a little bit more brown. Maybe throwing in some flowers in there. Doesn't have to be grass, some daisies or whatever, things like that. Some other weeds to break it up to make it look more natural. But yeah, those are things you can do on the side if you want. Like you have 2 emitters or 3 emitters, and each one can do different textures and whatever. Or like I said, do a texture atlas, and then and you can use the index ID as a way to kind of just alternate back and forth. It doesn't have to be random, because the location is random. So you can, like I said, you can use index ID to kind of just facilitate where in an atlas you want to use it. I did a video on atlases a long time ago, so if you guys want to learn how to do atlases again, just watch that video. So it's textural atlases. And at some point, we're going to do a level of detail, so we can go from far away and get closer. So there we go. So I'll end the video right like this. An assassin hiding in blades of grass, so the Templars can't see me before I stab him with my wrist blade. So yes, like and subscribe, please. If you have friends, tell them to subscribe. That'd be awesome. Like I said, I want to build up the user base and try to win that silver YouTube award. So yeah, hope you guys are having fun. This is great. We're getting better and better. We're doing more and more. We're getting closer and closer to building mini games or something. So yeah, we're gonna do some more particle effects and then go back to armatures, and then one of the other things would be terrains and voxels. So guys, see you guys in the next video.